Hello everyone. So basically, recently I went through this question. Uh, this is from a recent Codeforces contest, and what it says we are given a tree of n nodes, and there is one root node which is one, and every node has two values, either it is zero or one. And basically at time t equal to zero, there are n nodes which are nodes of a tree, and it is a rooted tree, and every node has a value which is either 0 or 1. Now what happens at after t equal to 0, what happens at any time, let's say t, the value of a node becomes bitwise job of values of its children, and if it is a leaf which has no children, its value becomes 0. So basically, let me show you one example. So this is at t equal to 0. There are 6 nodes here, and initially let us assume that the first node has value 0, second has value 1, third has value 0, 4, 0, 5, 1, 6, 1 at t equal to 0. Now at t equal to 1, what would happen? For leaf node, since it has no children, its value will become 0, and for other node, uh, so let's say node number 3, its value at t equal to 1 would become bitwise chor of values of its children at t equal to 0. So that would be, as you can see, 0. Yeah. Similarly, for you can see for node 1, bitwise chor of node 2 and 3 is 1. So its value as t equal to 1 becomes 1, while all the leaf nodes, its value at t equal to 1 becomes 0. Similarly, at t equal to 2, you can see for finding value of any node at t equal to 2, just you have to jor value of its children at t equal to 0, and that's it. Now this is like the basic understanding of the question is actually a bit different. The question says, let us denote st as the sum of values of all nodes at time t. So basically here at s0 is basically at time t equal to 0, sum of values of all the nodes, so which is, you can see, 4, um, 1, sorry, it's 3 at t equal to 0. At t equal to 1, s of 1 becomes 1. Similarly at t equal to 2, s of 1 becomes 0. So what they are saying, let us denote st as sum of values of all nodes at time equal to t for this whatever tree. Now fa denotes sum of st across all values of t, and what a is here, a is initial assignment of 0 and 1 in the tree. So for this example here, a is basically 0 1 0 0 1 1. Why 0 1 0 0 1 1? Because we have assigned this node 1 as 0, node 2 as 1, node, and this is at t equal to 0. So at t equal to 0, for this assignment, we can define f of a, where a is basically this assignment given to a tree. We can define f of a as sum of st across all values of t. Eventually you will find that here t is very large, but you do not need to go that large, as after some time every node of value of every node of this tree becomes 0. Why? Because as you can see, at t equal to 0, this is the initial configuration. At t equal to 1, all the leaf node becomes 0. At t equal to 2, the node which is like the parent of this leaf node becomes 0. Why? Because at t equal to 1, all values of its children is 0. So at t equal to 2, their bitwise jor will also be 0. And eventually you will find that around time equal to height of tree, this uh, all of the tree becomes 0. So basically this s of that t would also be equal to 0, and for every t after that. So here it says, for this configuration of a, we can define f of a as sum of st across all values of t, where a is basically this configuration of 0 and 1. Now what we have to find, we have to find sum of fa for all for all possible configuration possible. So you can see, like, if if we have a tree with 6 nodes, then total number of possible values for a is 2 raised to power 6, because every node can either be 0 or 1. For each of those values, for each of those 2 raised to power 6, 6 means 32 initial configuration, we have to find sum which is st, and then we have to add all those for all 32 configuration. As you can see, this here n can be very large to 10 to the power 5, so this value can go like very big, which cannot even fit in long. So basically we have to print the answer in mod 10 to the power 7. Now how to solve this? Like, I would suggest you to take a look. I will put this question link in description. I will suggest you to take a look at this question. I mean, it's a good question, and the good part is like it do not require any knowledge of any advanced data structure. Just a basic knowledge of like trees sufficient. Like, someone will suggest tree dp here, but I don't think like uh, there's anything related to dp here. I mean, yeah. So basically, the solution is like, if you see, like here we will use probability more precisely. Like, let's define it this way. So we are given this tree. Now if I will ask you a question, like, in how many cases, like let's say total number of possible configuration for this, we know it is like here it is 5 nodes, so total number possible configuration is 2 raised to the power 5. Now if I will ask you, in how many of this configuration this node will be 0, this this node will be 0, you will say 2 raised to the power 5 by 2. And in how many configuration this will be 1, it is 2 raised to the power 5 by 2. So basically there are 50% of chance, or in 50% of the total number of ways this node will be 0, and other 50 it will be 1. Same for this, 50% 1, 50% 0. Now at t equal to 0, we know for every node how many times it will be 1, so we know how much it will contribute to our answer at t equal to 0. We just have to go through each node and do this 50% value, which is 2 raised to the 5 by 2, so which is 2 raised to the 4 times all the nodes. This is simple. At t equal to 0, this will be our contribution toward the answer. Because what we have to do, we just have to calculate, like, let me define this question once again. So a, here is something called a, which is initial configuration, which is equal to 2 raised to the power n. There is something called st defined, which is sum of all values at time t at t. And then we have something called f of a, I think, which is for this initial configuration sum of all those, like for t equal to 0 to, let's say, very big. For this configuration we have to find this fa, and then for all those possible configuration we have to find sum of all those fas, whatever it is, for all possible configuration of a. Now, so as I said, at t equal to 0, every node will have 50% chance. I mean, 50% chance means 50% of times they will be 1, 50% of times they will be 0, and 50% total times, which means 2 raised to the power 5. Now what will happen at t equal to 1? I will like, here comes the interesting part. Yeah, so at t equal to 1, it will happen like for leaf node it's quite obvious, like it will become 0, it will become 0, it will become 0. But what would happen to this node? It can be 0, it can be 1. In some cases it will be 0, in some cases it will be 1. Is that true? Yes. In which case it will be 1? When in the previous initial configuration, when this was 0, this was 1, then it can be 1. When this was 1, this was 0, then it can be 1. When both were 0 in initial configuration, then this would have been 0 in at t equal to 1. So it can be both 0 or 1. Now if you find exact number of times this particular node is 0 or 1, then you will like get a hint to solve this problem. So basically what will happen, sorry, yeah, so basically what will happen, though uh, like for some number of times this node will be 0, for some number of times this node, but if you want to calculate how many times, then you will eventually get the answer. This is because we know at now we are calculating for t equal to 1, and t equal to 1 is totally dependent on t equal to 0 for children, for child nodes. And you know for what happens at t equal to 0. At t equal to 0, this has 50% chance of 1 and 50% chance of 0, and same for that. So at t equal to 1, when you will do JOR of both, then also the, this node happens to be 50% chance of 0 and 50% chance of 1. I will suggest you to think more about this. And eventually, not just for t equal to 1, for any time, you will find for any time, for any given node, which can be anywhere, even for this node also at any later time. Let me show you like this. So at t equal to 0, you know this has 50% chance of 0, 50% chance of 1, this has 50% chance of 0, 50% chance of 1. That's why at t equal to 1, this node will be, at t equal to 0, this node will have the same, but at t equal to 1 also, this node will have 50% chance of 0, 50% chance of 1. Why? Because at t equal to 0, its child have 50% chance of 1 and 0, and we are doing JOR. So you can think it like this, like JOR is basically if both are 0, then it's 0, if both are 1, then it's 0, if 1 0, then it's 1, and 0 1, then it's 1. So as you can see, like there is equal weightage given to both 0 and 1. And for children, for children there are 50% chance of 0 and 1. So it also will have 50% chance of 1. Why? Because both are having equal weightage, 0 and 1. That's why. I mean, this is a hint to think more in this. Um, Maybe the full answer also. Yeah, so what I said, for all the nodes at t equal to 0, they have 50% chance. Eventually you will find that at t equal to 1 also, these nodes will have 50% chance. Because why? Because their children has actually 50% chance of becoming 0 or 1. So this is basically hint of this problem. One thing which I would like to add more on this is basically what will happen for this node at t equal to 1. At t equal to 1, this do not have 50% chance of becoming 0 1. This has basically 0% chance of 1 and 100% chance of 0. Why? Because as I said, this has no child node. That's why at t equal to 1, it will become 0. It is given in our problem. So and for this node, if you will see, at t equal to 0, it has 50% chance of being 1 or 0. At t equal to 1, it has 50% chance, but at t equal to 2, it has basically 0% chance of 1. So similarly for this node, at t equal to 0, it has 50% chance. At t equal to 1, it has 50% chance. Why it has 50% chance at t equal to 1? Because as we discussed, this has 50% chance of 1, and this has 0% chance of 1. So 0%, we can just ignore them. You can also think why. So we can think it has only one children, and which has 50% chance of at which has 50% chance basically at t equal to 0. So at t equal to 1, sorry, we are talking about t equal to 1. Yeah, so at t equal to 1, basically it has two child node. Both of these child nodes have 50% chance of becoming 1 at t equal to 0. That's why it has 50% chance at t equal to 1. Now if we talk about t equal to 2, then we will find that this node basically has 0% chance of 1. We can just ignore it, and this node has 50% chance as t equal to 1. That's why at t equal to 2 also this has 50% chance. At t equal to 3, you will find that both of its child node are 0, so it has 0% chance. So here is one key observation here, that up to this depth of this node from the last, at that time it has 50%. After this it has 0%. What I mean, like this node has basically depth 0, so only for t equal to 0 it has 50% chance. After all t equal to 1 and so on, it has 0% chance. This node has depth from like bottom, it has depth of basically we can say 1, let's say. So only for t equal to 0 and t equal to 1, it has 50% chance, while for others it is 0. Similarly for this, it basically for up to t equal to 2 it has 50% chance. So for 0 1 2 it has 50%, while for others it is 0%. So our final solution would be, what we will do for any node, calculate its depth. Then what we'll do, as we know, up to um, 0 up to that depth it has 50% chance, so that means half of total number of possible ways, so 2 raised to power n, that's it. So up to 0 to this depth we have to add this much to our answer, so that means 2 raised to power n minus 1 times whatever this depth plus 1, that's it. This is our answer, and this we have to calculate for all nodes.